Today is January 18th. So what I've been up to is I've been working on a new version of the documentation with more capabilities. We went over this last week as well, and I found a pretty cool feature that I wanted to show. So let's see. So here we are in WriterSide. That's JetBrains tool to create technical documentation. And here I've been working on mass transit. So it's a demo, or it's a documentation about the mass transit activities. And let me see if this is correct. So it should not belong here. It should be here. So I just moved this topic underneath activities library. And the idea here is that we will have more activity types. So maybe hang fire will be here, looping activities, etc. So this library will be a library of activities, and then there will be a section about writing custom activities. So everything can be found underneath activities. I might change this structure based on feedback and new insights, but this is what it might be for now. So let me open this in Chrome. So, and I'll refresh. So here we see the mass transit tutorial, the documentation page, I mean, which starts here. And what I discovered is the following. So here on the top right, we see a little drop down, and this label is configurable, including the values. So you can have some sort of variation of your page. So why might this be useful? So here we are talking about mass transit, and as you may know, mass transit is a package that allows you to talk to a various set of message brokers. For example, or you could talk to Azure Service Bus or RabbitMQ or Kafka. So you can imagine if you set up mass transit, you will have different configurations depending on your message broker. So here I have an example where I talk about setting up the mass transit module. And as you can see here, I'm adding Elsa to DI, then enabling the mass transit feature, which I then configure here using mass transit. And now at this point, you probably guessed it. When we change this to Azure Service Bus, we also see the code snippet updated to reflect this change. So that's a pretty neat feature of this documentation engine from WriterSide, I think. And when using the memory provider, the code is much simpler, of course. And this applies throughout the page. So if we go to the tutorial, so here we see project setup for mass transit, but when we change this to RabbitMQ, we see a specific tip when using RabbitMQ. And in this case, I'm explaining that in order to try out RabbitMQ, you can just spin up a Docker container, which is easier to work with when compared to, of course, Azure Service Bus, in which case you will have to create a resource on Azure and connect to that. So yeah, so this is a work in progress. I'm porting over all of the existing documentation and then expand upon that and add more documentation. And this is documentation that doesn't exist on the old, or well, the current documentation, I should say. It's not yet old. Yeah, and so there will be more topics here. Currently, I think I left off at Elsa server. And yeah, this one is next, Elsa Studio. So yeah, that's that about documentation. Somebody created a pull request to enhance Elsa Studio a little bit when working with sub workflows. So that's the following PR. That's this one. So Marius created this little section here. So what we're looking at here, oh, never mind. So here we have a workflow instance viewer. So we're looking at the workflow instance, and we are part of a activity that is actually implemented as a workflow. So here we're looking at that workflow that's called sub1. So it's like a sub workflow. And before this PR, you wouldn't see this section. So you would always see the workflow details here, which always represent the workflow properties of the root workflow, if you will. So that's the main workflow. But when you drill into the sub workflows being invoked, it might be useful to understand things like what is the name of the workflow, so and including definition ID, so you can directly navigate to this workflow definition and make any changes or do some inspection, whatever you're doing here. So that's a nice little enhancement. So yeah, actually, let's see this in action. I prepared a sub workflow here. So this is This is actually just a workflow. It's called sum, but it's configured to be usable as an activity. And what that means is that means you can regard this workflow as like a subroutine in a programming language. So it can have inputs, so input parameters, in this case numbers. So this is an array of doubles, and the result. So the result is the sum of whatever set of numbers you put in. And the implementation is very simple. So the implementation is done using run JavaScript activity. And then it uses the reduce function on the array, the numbers array that we receive here as an input, and do the sum of each individual element. It sums it to the previous value using the reduce function. And then its output of this activity that we receive here, so this run a JavaScript activity produces a result, which is being bound directly to the result output that we see here. So very simple implementation. So the bigger point, of course, is that this is a sub workflow, or it's a workflow that can be used as an activity from another workflow. So let's look at the calculator workflow, which is another one. And this one uses the sum activity, which is configured to with the inputs numbers just being a small array of 3 digits. So that's being passed in as input, and then the output is captured in a variable called the sum. So when we execute this, we see the input here, we see the output, and we see the definition of the sum. So this is a way to go directly to the definition of the sum activity. When we double click on this one, we drill into the execution of this workflow. So we went from root to sum1 root, and then we see its activity. So here we're looking at the sum definition, but from the perspective of the workflow instance that was created. And what we see here now is this sub workflow section, so that we can uh, identify that this thing here that we're looking at is actually the sum workflow. So the activity type is sum, and since it's not prefixed with any namespaces, you can make an educated guess that this is a workflow definition, and this guess is confirmed, of course, because it has a definition ID, and the definition ID will take you to the editor of this workflow, and then we can make any changes if we wanted to. So there you have it, a nice little enhancement to more easily navigate from workflow instance viewer to sub workflow definitions. So thank you, Marius. That's pretty cool. Another thing that I've been working on for a customer is the ability to dispatch child workflows in bulk. So they're going to use it to implement batch processing of a set of records that they have, like a few million of them, and each record needs a sub workflow to be processed. So we are designing a way to have the ability to load in data in bulk, but in chunks. So we're not going to load all 2 million records in memory. That's not going to work. So we need a way to load these records in little batches or in chunks, and then have the ability to dispatch sub workflows for those individual items in those batches. And we want the workflow to continue working through all 2 million records. So I basically have two designs, two suggestions, really, that we're going to discuss tomorrow, and I will just show it to you guys here and talk a little bit about it. Excuse me. So let's see what we have. So the first option is as follows. So we have, let me see, we have a order processing workflow, and it works like this. So we have, it's a self-contained workflow. It starts with a write line, which we can ignore. But the idea is it's emulating some database operation. So fetch orders. It's going to fetch 100 items in chunks of 5 items at a time. So this thing here, let's look at its implementation. That's orders. This is the implementation. It's using, I think it's bogus. Yeah, so it's using the bogus package to generate fake data for a model called order, which is a simple class. It carries these members. And of course, in a real world scenario, this would be loading orders from a database or some other data store. Here we are emulating it. But the purpose of this activities is that it's producing an async enumerable of a collection of order. So this is like a streaming object, so to speak. And each item is a chunk of data. So this would be, if the batch size would be 100, every time you iterate over this enumerable, you would get access to 100 orders at a time. So 100 orders will be in memory at any given time, if there are at least 100 orders, of course. And so the key here is that it's returning an IAsync enumerable uh, here. So here we are returning orders. Here it's built using the private generate orders function, which is just a normal enumerable, but we're returning it as a async enumerable, and we're chunking it here upfront in memory. Of course, when querying a SQL server, you will be querying 100 records at a time and then yielding it basically. So yeah, so the point is returning an IAsync enumerable, which we are capturing here in the result using the orders variable. So the orders variable is of type object, which means it can store any kind of value, including this IAsync enumerable. This is pretty hard to read, so we should configure Elsa to have an alias for this type, which can be done at the program level. But for now, it's just this ugly type string. But it's configured to be captured in orders. So the orders variable will carry the IAsync enumerable instance, which can be used by certain activities. At this moment, there's just two of them in this branch. One of them being the parallel for each, which hasn't changed from the outside, but internally it knows about async enumerables. So it can deal with enumerables for its items, but also async enumerables. And when you give it an async enumerable, it knows how to iterate over it, and it will then receive one chunk at a time, and then it will of course iterate over each chunk in order to execute this body activity for each individual order. And speaking of which, this is a very simple implementation of the body. It will just write out which order it's processing at the moment. And then once this is all done for all of these items, right? So if we generate 100 items, regardless of the batch size, ultimately this parallel for each will dispatch, or it will schedule the body activity 100 times. And then once that's all done, we'll end the workflow here. So let's run this one. But that's done. So we said, okay, here's the fetch order. The result being an async enumerable is not serializable, so we're not seeing anything here. This one received the items, which we can see its type is an async enumerable. When we drill into the body, we see that indeed the write line has executed 100 times exactly. And then, of course, it just writes out the ID of the generated orders. So this is one approach where we simply provide the async enumerable as the output of a custom activity. So this is now a custom activity. It could be querying a SQL server or a Redis store or a GraphQL. That doesn't matter. The idea being this is custom made, but having the ability to produce async enumerables that can then be consumed by parallel for each. Another activity that understands async enumerable is the bulk dispatch workflows, which is a relatively new activity that can dispatch multiple child workflows instances based on a given input, and the input being a set of items. So here we have the same fetch orders activity, which we capture in a variable called orders again. And that variable orders we are using here as input for the items input for bulk dispatch workflows. So for each individual order, the batch item processor workflow will be dispatched. And this happens sequentially, so it's running through all of the orders it gets from the items input and immediately dispatching the workflows, which means it's filling up a queue, and this queue is then being processed by background workers, which there could be multiple background workers on the same node. When you're in a distributed environment or in a cluster, each node in the cluster, of course, will have the ability to process this queue. And the more nodes you have in the cluster, the bigger, the higher the throughput of those child workflows finishing their work. So that's the basic idea. And here too, it will receive it. This one understands Okay, so I don't know what device I was talking through. I hope it got recorded. I just noticed because my headset was turning off that it wasn't receiving any audio, so I was on the wrong device. Hopefully, the audio wasn't too bad, or at least it was captured, and hopefully now at least it will be better. But I will check after this session. All right, where was I? Okay, so the bulk dispatch workflows also understands async enumerable. Yeah, so you can give it an async enumerable that can potentially contain or produce millions of items, doesn't matter. It's just gonna process it in chunks. So here what we are doing, we're gonna dispatch this batch item processor, and then once all of the child workflow instances have completed, the finished outcome will execute, and then the final activity will execute. So before we run this, let me do a little bit of cleanup. So I'll delete all of the existing instances. And then before I run the batch processor that we just looked at, let's also have a look at the batch item processor, which is the child workflow that we're dispatching. And this one too, it's very simple, but it's showing how you can access the input item. So in this case, the order. And by convention, the parent workflow or the bulk dispatch workflows activity provides the current item as input to the child workflow instance through an input named item. And you can strongly type it if you want by adding an input in the child workflow definition by calling it item. And then you can use the JavaScript get item. If you didn't define this input, then you would have to use get input and then say item. So this will be the alternative syntax. But since I define it here, I can use the strongly typed function name, get input, get item. Yes. All right. So let's see how this works. We'll press play. All right. So it's currently executing, and this is using an in-memory queue to be fast, but there's some bottleneck somewhere that I need to look at. I'm not sure what's causing it, but it's not as fast as I would have expected. It could be just configuration on mass transit or something along those lines, or maybe it's even connected to Azure Service Bus, which we can find out immediately because I'm running Elsa Server Web. Let's see. Okay, so we are using mass transit, but we're not using Azure Service Bus. So I'll take a look why it doesn't basically finish immediately, but it should be done now. Let's refresh. Okay, so the bulk dispatch workflows is completed. It finished its work, and we can see here that for each item in its internal iteration on the orders async enumerable, it reschedules itself. Or actually, it creates a bookmark for itself that can then gets resumed by a domain event handler called which handles the workflow executed event, which is fired whenever any workflow finishes. So these are the child workflows that finish. They yield that event, and that is handled then by this activity or the handler of this module that then resumes this activity. And this, the reason for this is that it allows you to execute some additional activity in response to a child workflow instance being completed or faulted. Maybe you want to do some cleanup or notify someone when something finished or faulted. So that's why you see a lot of these journal entries here. So it should have created many workflow instances, 100 to be exact, which is correct. So one is, of course, for the main workflow, and the rest is for the child workflow instances. If we look at a random one, we see that it was able to receive the order because it's able to print out its ID. So that's the current state of affairs for bulk processing. Actually, that's not true. This was just one design producing the async enumerable. What might be a potential disadvantage to sending a non-serializable async enumerable is that what happens if the process crashes midway or midstream? Maybe it's at some point it's at the third batch, and then the container gets killed. Then there's no way to recover from that other than just restarting from scratch. So then it might it will have to start from the first batch and the second one, etc. So that might be a potential disadvantage. or maybe it's not a disadvantage depending on your requirements, but let's say it is an issue. What other strategy might we employ? So that's another experiment that I have here. So here we have another workflow called product processing. So similar to fetch orders, here we have fetch products, but it works a little bit different. So here the return type is not an async enumerable. Instead, it's just an individual batch that it produces. So the fetch products, similar to fetch orders, can return any number of records. Could be a million. Let's do 100 for this demo, like with the orders. But this could be a very large number. But it's going to produce chunks with a size of 5 items per chunk or per batch. So that's the idea here. This activity will produce a single batch, which can then be processed by the parallel for each, which in addition to understanding async enumerables, of course, it also understands simple arrays and enumerables. But what this thing then does, it's going to reschedule itself. So it's going to produce the output, it's going to complete itself, but it's also going to complete, a schedule itself for the second batch and then for the third batch, all the way until there's no more items to be produced, which also means, in effect, this activity will execute multiple times, which also means this one will execute multiple times. And that could be regarded as a disadvantage because when we run this, we'll see that this one executed 21 times as did this one. And of course, this one will have executed 100 times. But this may or may not be desired, but functionally it works. But the fact that it generates so many executions of an activity might feel like a little bit of a workaround. And that's my current opinion. It feels like a workaround. It's nice. It's effective, but I think we can do better. To get some inspiration, I started to look at Azure Data Factory in a little bit more detail. I don't have any experience with it. I need to try it um, interactively to get a feel for it. But based on the description, there's a few really interesting concepts that I think we can explore in more detail. And to that end, I created a new feature, a new issue called Data Processing Pipeline Concepts, where I more or less try to capture the essence of what I learned so far from Azure Data Factory. And what really interests me is their concept called dataset. From the description, it's a little bit like Elsa's variables together with the storage drivers concepts, allowing you to store a variable value in, for example, blob storage or Redis, other than just in the workflow instance itself or even in memory. Azure Data Factory also has a concept of variables, but there a variable, from my understanding, is per definition transient in nature. So these are temporary values that you can use. But data sets, they are like variables with a storage driver on steroids. So it's basically a pointer to a set of data that you want to read from or to write to. So you can also create data sets on the fly. And a data set could be stored on a connected service representing, or a connected service is more like a connection string to some service where the data set exists. I could be wrong on this. This is my current understanding. I'm still learning. But the idea so far, I think, is that an example of a data set on a connected service could be SQL Server. So you can define a data set, maybe a view of some data on a SQL Server that then can be consumed by a given activity in Azure Data Factory. And then such an activity could query this data set, so it would retrieve the items in chunks, and then produce it as a resulting data set, which could be stored also on a SQL Server or potentially even on blob storage or Redis or some other. They have a lot of data set targets that you can use, a lot of connections that they have. And the idea, of course, is having the ability to get this information, the activity does something with it, so it reads it and then transforms it maybe, or it maps the data, or maybe straight up copies it to the target data set. And then a second activity in the pipeline, as they call their workflows, would get a reference to that same data set, maybe the reference to the target data set, or they call it the sync data set. And that would then be used as an input into a second activity, which can then perform additional work. Each step in the pipeline, each activity in the pipeline executes on a given node in the cluster. So these are like background job activities in Elsa. So we already have that implemented. So that should be easy. Adding this concept of connected service is very useful. We need something like this anyway, also for other kinds of activities, like maybe having the ability to query a SQL server directly, not in an abstracted way as maybe it's done with Azure Data Factory, but you don't want to be hard coding connection strings into input fields. You want to either get it from a variable or even better, have getting it from a drop-down list called connected service, for example. So this is a useful concept to have in any case. And then, yeah, I think that's more or less the gist of it. So I'm going to play more with Azure Data Factory, get some more information and knowledge about it, and try and port over some of the ideas to Elsa to really optimize the use case scenarios for loading and transforming data without having to deal with serialization issues or with the workflow instance document exploding in size, or having to deal with variables and configuring them to be stored elsewhere. Maybe the dataset concept can add some really powerful functionality to Elsa. So this is what I've been up to for the past week. Somebody on Discord asked about events, and I promised to show this on screen during this meeting. So let's do just that. Let's see. So what is this user trying to do? He wants to trigger the event with Event Publisher, but from Studio. So the first thing is that you currently can't publish events from the studio. Let's see if we can model his workflow. Okay, so let's go through the motions. So we're gonna set up a new workflow, and we'll call this. Let's call this the receiver. So we'll have a workflow that receives events. So from primitives, we'll receive an event here. And here he's not using it as a trigger for the workflow, so he's starting the workflow himself. So let's do that as well. So we'll uncheck the trigger workflow. So now it's no longer a trigger, it's just a blocking activity. And we'll start this one off with maybe just a start activity, which it by itself doesn't do anything. It's just like a little milestone, a starting milestone in this case. So this one starts, then in this event, we'll wait for an event called some event. And he also has a timer. So I think actually in this case, we don't want to use a timer, although functionally it should behave the same as a delay activity. But I'm contemplating an enhancement to timers that they become generator activities. And a generator activity, the concept is that, let me just show you. So let's say we are going to add a timer, then this is going to flow into some subsequent activities. Currently, when when a workflow executes, it goes from one activity to these two, and then it continues on. And then so basically the pointer, so to speak, the execution pointer moves on. But when you have a generator activity, no matter what executed in the workflow, as long as the workflow is running and not completed, this could generate an event. So this timer could execute, and it would execute all of its subsequent activities repeatedly, no matter where execution in the workflow is. This is still a work in progress, something I'm exploring conceptually. So it's not there yet, and it may never be part of the engine if it turns out not to be a good feature. But I need to do some experiments with that. So now I recommend using the delay because this is not a trigger. It's explicitly a delay in the workflow, because when using a timer, it does cause some confusion to some users, not realizing that it will execute just once when this activity executed, and then it will create a bookmark and then trigger at the specified interval once and then continues onwards. So the delay is better for this case because it's more explicit, or semantically correct, I should say. All right, so let's see here, it's waiting for the event. Oh, and here is maybe that's what he's going to do. He's going to publish this event I guess. Let's see if that works. So then he is going to run some C# and I can't see the rest. So let's try that. Let's say after 5 seconds, we're going to publish this event from the same workflow. We go to primitives and say publish events, and we're going to publish some event. And since this is in the same workflow, we can say publish to, it's a local event, so only publish to this workflow. You don't have to, but if you don't, and there's other workflows waiting on the same event, and you're not filtering using any correlation IDs, then all of those workflows will be triggered. And this may or may not be desirable depending on your requirement. So in this case, it's intended to just affect the local workflow instance. So I'm going to check this checkbox. And then when this is executed, it will cause this event to be resumed, or to be triggered. Yeah, it will create a bookmark, which means it will be blocking. Once it's triggered by this one, we'll be able to resume. So in this case, they're using run C#. I don't know what it's doing, but we'll just do a write line. So we'll do it like this. So we'll add another write line here, move this over here, and here we'll say waiting for event, and here we'll say event received. All right, so, and here we're going to publish the event. All right, let's see if this works. So the name of the workflow no longer makes sense because this is the publisher and the receiver. Okay, so we're waiting. The real-time view is currently a little bit broken, so it's not going to refresh unless I refresh. Let's see what happened. So start executed, that we see here, then write line here started. So this one got executed. Then the delay got started and suspended, of course. And then the event got executed and suspended. So both event and delay created a bookmark at this point. And then as we can see here, 5 seconds later, the delay got resumed by the timer trigger and then completed. Then of course, publish event executed and completed. And that caused event 1 to be resumed and completed. And then finally the write line. So this is one way to work with event and publish event. Now, let's go back to the description of the user. Maybe we understand what the issue is. So he's saying I want to publish an event calling and endpoint. The event has to be in the body, a long number, but the event has to catch to use in the C# script. Which setting on the activities I have to use and how can I publish the event? I can use also Postman. Okay. And he says, I think he tried to use Postman, but then he got an error. So Elsa API events. So the response here seems to be a Blazor thing. So it looks like he's using Elsa server and Studio in one. So let's do that as well. So here I'm gonna stop this application and switch to, all right. So we got Elsa server and Studio started. So now what we're gonna do is we're gonna create a new workflow. And then we're gonna cause it to wait for an event and then trigger this event from Postman. So this is gonna be, let's call it a listener. We are going to add a start activity and then we're gonna add a event activity. So we're gonna wait for an event to be triggered and we're gonna use Postman to do so. And then we will have end, which by the way is optional. You don't have to use a start or an end activity, but it's a nice practice to explicitly demarcate the start and end. So let's say some event. It doesn't. It shouldn't trigger new instances. So we're gonna uncheck the trigger workflow checkbox again, and that should be it. So let's let's run this workflow. So now we are waiting for an event to be triggered called some event. So we're going to trigger some event using Postman. So for that, we have an endpoint here, and let's call it, let's use this one, trigger event. So the way this works, you invoke the events endpoint, provide the event name as part of as a route parameter, and then the trigger action. And I think the API address is correct, but maybe this is the issue. Let's see. You can optionally provide some settings in terms of, for example, the workflow execution mode. Should it dispatch the execution to the background, or do you want the workflow to execute in the foreground? So I think my headset just dropped again. Maybe because I'm not receiving any audio, it stops. Anyway, I hope that got recorded. So let me rephrase. The workflow execution mode allows you to execute the workflow in the background or in the foreground, also known as, in this example, within the HTTP context. And optionally, you can provide some input. In this case, the workflow will do nothing with this. So we'll leave it here. So when invoking this one, we got a successful response and not the HTML response from the user. So at this point, we haven't reproduced the issue, but let's see here when we refresh, just to make sure it worked. And yes, so it did work. So event one got resumed, completed, and then of course the workflow finished. So yeah, I guess this is an invitation to this user to provide steps to reproduce. At this point, we can only try and guess and see if we can manage to reproduce, but from the information I've seen here, it works on my machine. So yeah, I will ask him to send a repro, and we can investigate later. In any case, I hope this was instructive to get a bit of more information on how to work with events and publishing them. If you have any questions, please let me know down below in the comments. And thank you for watching.